ABCD is a quadrilateral. EFGH have the midpoints. AH is vector A, AE is vector B, and DG is vector C. We need to prove that EFGH is a parallelogram. So first thing I've done is I've worked out the vector BC. And I've done that by going from B to A, which is minus 2B, plus A to D, which is plus 2A, plus D to C, which is plus 2C. So that's what I've written there. Then they're asking us to prove that EFGH is a parallelogram. So key thing about a parallelogram is that the opposite sides are going to be parallel. So that's what we need to show. So I've started off with EF, and I've said that EF is the same thing as E to B plus B to F. The E to B is just vector B. The B to F is half of the B to C that I just worked out a moment ago. So half of the minus 2B is minus B, half of the 2A is A, and half of the 2C is C. Then, collecting those like terms together, the B's cancel out, and I just get left with the A plus C. So we've worked out that the vector E to F is A plus C. I've then worked out the vector H to G by going from H to D plus D to G. H to D, that's vector A, and D to G, that's vector C. So adding them together, we get A plus C. So the E to F, this vector here, that is A plus C. The vector H to G, that is also A plus C. So those two vectors are parallel and also equal in size, as you'd expect for a parallelogram. Then in purple, I'm going to work out the vector E to H. E to H is going to be E to A plus A to H. So minus B plus A. And then F to G. I'm working that out by going F to C, which is half of this, plus G to C, which is minus, C to G is minus C. And then collecting the like terms together, the two C's cancel out, and I get minus B plus A, which was the same thing as the E to H. So we've worked out that these two vectors are again equal in size and parallel in direction. So therefore we've worked out that E to F is equal to H to G, so they are parallel. E to H is equal to F to G, so they are also parallel. And we know that the opposite pairs of sides are parallel, means that that is a parallelogram.